Hello, Honors Algebra 2. So we are going to be quickly reviewing R1 and R2, which is essentially an Algebra 1 review with one new thing added in there. So let's get to it. R1 and R2, which is an algebra review. Okay, so what we're going to start with is just a review of order of operations. So let's start there. Order of operations. You guys will see I have a hard time with spelling, so I often will sound it out as I say it. So please don't fault me for my poor spelling skills. Okay, so remember the order of operations. Most of you guys, I'm sure, have heard PEMDAS or GEMDAS. Please excuse my dear Aunt Sally. We're going to go with GEMDAS. So GEMDAS, what that stands for. So the G, if you're unfamiliar with why we do G instead of the P for parentheses, G is just more inclusive of all grouping symbols. So G is for grouping symbols. E stands for exponents. M stands for multiply. And D stands for divide. Now, these actually don't have a specific order. Sorry, that was a weird E. What these are, the importance of, I just made it even weirder. So just here it is. Okay, so what these are, multiply and divide, you can do those in, you don't have to multiply before you divide. What you do have to do is solve from left to right. So if the division comes first as you're reading it through left to right, then you need to do the division first. And then we have A for add and S for subtract. And now those two are the same as multiplying and dividing. You want to solve them from left to right. Okay, so I'm going to do an example. I'm just going to do the example over here. Okay, and my example is going to be, 30 divided by 5 times 2 minus 8 minus 10 plus 6 squared. Okay, so let's deal with that piece by piece by piece. So grouping symbols. Our grouping symbols, the only thing we have here are parentheses. Other examples of grouping symbols, parentheses, brackets, absolute value symbols, those would all be the first thing you want to deal with. So 2 minus 8 is going to be the first thing I simplify. 2 minus 8 we know is negative 6. And then I'm just going to bring everything else down. I know some of you guys are like, we can simplify more, but I'm just, for sake of doing an example, let's do it step by step. Oh, I just jammed my finger. Okay, so then we're going to go into exponents. 6 squared. So 6 squared we know is 36. I'm not going to skip 2 lines here. 30 divided by 5 times negative 6 minus 10 plus 36. Okay, so then what we're going to do, we've done our exponents, we've done our grouping symbols, we're going to multiply and divide from left to right. Now, this is where I'm assuming some of you guys are getting tripped up because you wanted to multiply that 5 and negative 6 together first, and you can't. So what you need to do first is divide from left to right. We see this 30 divided by 5 first, so we're going to do that first. Not this, because that comes second. So 30 divided by 5 is actually 6. So 30 divided by 5 is 6. And then we're going to multiply by negative 6. And now I can actually multiply those two together. So 6 times negative 6 is negative 36 minus 10 plus 36. And then I can just put that whole thing in my calculator. Now, one important thing to remember when you guys are putting this in your calculator, when you guys are putting negative 36, don't use the minus. That's going to get you a syntax error. Use the minus here. So that's a negative number. So negative 36 minus 10 plus 36 gets me, hopefully you do that in your head, negative 10. And there you have it. So that is our order of operations example. I'm going to continue on, and I am going to talk about exponents. Okay. So this should be a review of Algebra 1. So I'm just going to start by reminding you guys of the 5 important rules of exponents that I do want you guys to have memorized. So first one, we're thinking, what is anything to the 0 power? Anything to the 0 power. We can always, if we don't know, if we don't have that one memorized, we can go, well, what's 8 to the 0 power? And it's 1. What's 5 to the 0 power? It's 1. Anything to the 0 power is 1. Okay, and then what we want to talk about is also if we have a negative exponent. So a negative exponent, if I have x to the negative m power. So if it's a negative m power, to make it positive, we move it to the denominator. So that would become 1 over x to the m power. Now, if I had it the opposite, so let's say I had, let's do it below, 1 over x to the negative m power. To make that positive, I would move it to the top. So I would move it to the top to make it positive, x to the positive m power. Okay, let's look at our next rule. So our next rule is when we're multiplying. So x to the m times x to the n. So when we're multiplying and they have the same bases, what can we do with the exponents? If you're thinking, add the exponents, you would be correct. So it would be x to the m plus n. Okay, let's try dividing. So if I have x to the m over x to the n, when we're dividing, what do we do with the exponents? And if you're thinking subtraction, you'd be correct. So it would be x to the m minus n. And then our last one is power to a power, which we talked about in our last video. So power to a power, x to the m raised to the n power. So power to a power, we multiply. Okay, so let's do an example. I'm debating if I want to make this like a doozy of an example, which I feel like I should. So let's do that. Oh, the air just turned off. And it's about 1,000 degrees out right now. So hopefully I can get through the next video without the air. Okay, so my example here is going to be 3x y squared to the third power, 2x squared y, x to the fourth y to the squared to the negative second power, all over negative 9 x to the fourth y to the negative third. Okay, so I gave you a doozy, but I want to talk to you guys about these. Honestly, I know this one looks hard. It's not. I just want you guys to take it part by part by part. So the first thing I would always do is make all my negative exponents positive. Now, I say that and I want you guys to do that, but if there were negative exponents within these, I wouldn't want you to make those positive first. I would want you to deal with any of the negative exponents on the outside first. So let's start there. I'm going to start here, and I'm going to make this positive. So to make this entire thing positive, all I'm going to do is move it to the bottom. Now, if this had something on the outside, I wouldn't touch this negative yet, but because it doesn't have anything on the outside, I'm just going to move it to the top. And then I'm going to rewrite it. And I know some of you guys are going to be like, come on. But I'm just going to show you step by step by step. So we have, let's see, 3x y squared cubed, 2x squared y. This is moving to the bottom. This is moving to the top. So I'm just going to write it as, and you know what, I'm just going to put it in parentheses. Y cubed. You don't have to put it in parentheses. All over, I'm going to put this in parentheses, negative 9x to the fourth. And then that's all going to be in the bottom now. So x to the fourth, y squared, now with a positive 2 exponent. Okay, so I made any of my negative exponents positive. Now what I want to do is I want to distribute. So I want to distribute always next. So that means I want to get rid of the exponents on the outside of the parentheses. So that means I'm going to deal with this guy here. I'm going to distribute the 3 here, here, and here. And then I'm going to distribute this 2 to the x to the fourth and y squared. So that's going to be my next step that I'm going to write out. So 3 cubed, 3 times 3 times 3 is 27. I'm going to skip a line because I feel like I was cluttered there. X cubed is just x cubed. Y squared cubed, multiply my exponent, so I get y to the 6th. Times, this doesn't have any parentheses on the, or any exponents on the outside, so I'm just going to write it as 2x squared y times, that didn't either, so times y cubed. All over negative 9x to the fourth doesn't have any exponents on the outside. This one does, so x to the fourth squared is x to the 8th. Y squared squared is y to the fourth. We're just multiplying. 4 times 2 is 8. 2 times 2 is 2. Then I combine my like terms. So I would combine anything that is the same. So anything that I can multiply or anything that has a like base. So I'm going to look for those things. So okay. So I can combine 27 and 2 and multiply those together. I can do that on my calculator. 27 times 2, if I can't think of it off the top of my head, which apparently I couldn't today, which is 54. I can combine my x cubed, my x squared, and combine those. When they're multiplying with the same base, we can add them, so it becomes x to the 5th. Oh, that air turning off is, we're feeling it now. Okay. Y to the 6th can combine with the y and the y to the 3rd. So I add my exponent. 6 plus 1 is 7 plus 3 is 10. And then we deal with the bottom. Negative 9 can't combine with anything. X to the 4th and x to the 8th. Again, we add, so that becomes x to the 12th. And then, I have one last color. Oh, y to the 4th. Nothing to combine it with, so I'm just going to write it down here. Oh my gosh, and you couldn't even see that. I'm sorry. I'm going to move it up. So we have the 54 from the 27 and the 2, the x to the 5th from the 3 and the 2, the 10 from 6 plus 1 plus 3. Remember, when there is no exponent, we can always assume there's an exponent of 1. And then the negative 9 can't combine with anything. 4 plus 8 is 12, and then y to the 4th comes down. Now comes the fun part. I can simplify. Does negative 9 go into 54? And it sure does. It actually goes in 6 times. So we're going to actually just put the -6 on top and the 1 on bottom, which we don't actually need the 1. Now, when I'm simplifying x to the 5th and x to the 12th, I look to see which one is bigger. The one that's bigger is the one in the denominator, the 12. So that means my x's are going to stay in the denominator. So 12 minus 5 is 7. So x to the 7th is going to stay in the denominator. Okay, y to the 10th over y to the 4th. Again, I like to see which one is bigger. The one that's bigger is the 10. So that means the y is going to stay in the numerator. 10 minus 4 is 6. So my final answer is -6 y to the 6th over x to the 7th. If you take it piece by piece, yes, this might have been a longer problem. Yes, it looks like a big problem. But if you take it piece by piece by piece, it's really nothing scarier than what you guys are used to in Algebra 1. Okay, so we're going to do one more thing. This is going to be new, so I'm actually going to turn my page over. And we are going to talk about domain of functions. Now, the domain of functions is something that I'm going to introduce to you right now. We're going to deal with it heavily in chapter 3. Yeah, I think it's in chapter 3. And so right now, we're just going to talk about it. Okay, so we're only going to be dealing with one function, but let's first start talking about what does domain mean. So domain for this is the set of all x values for which a function is defined. So that's kind of like the math way of saying it. The set of all x values for which a function is defined. Now, with that being said, what that really just means is if I have a function, and I'm going to give you one in a second, but let's say I had a linear function. Remember, when we're looking at a graph, I'm going to graph something really quickly so you can see that. Oops. Okay. So if I'm looking at a graph, the domain is from left to right. We're looking at it from left to right, which is all of the x values. And this is all real numbers, which in interval notation, which hopefully you have seen, which we're going to talk about a little bit right now, is from -infinity to +infinity. We write that in parentheses. If I were to write a different graphing, like a different one, like x squared -3. So from left to right, we actually goes on forever. This one's also -infinity to +infinity, all real numbers. Because if we think about this function, x squared -3, I can plug in 0, I'm going to get a number. I can plug in a negative and I would get a number. I would plug in a positive and I would get a number. So anything into x squared -3, I'm going to get an output. Now, what we are going to look at right now is we're going to look at what we call a rational function. A rational function is when we have a variable in the denominator. Okay, so let's get into an example. So our first example is just going to be find the domain of f of x. Remember, f of x is just like a fancy way of saying a function, and that's an f of x equals x minus 3 over x squared minus 5x plus 4. So this is, like I said, a rational function. A rational function, again, is something that is has a variable in the denominator. So there's a variable x and there's another x in the denominator. So if we think about a fraction, what makes a fraction not work? When can we have, like, what makes a fraction kind of like explode? Maybe we're thinking a positive number. Well, if I plug in any positive number, I'm still going to get an output. I'm still going to get a number, which we could even like plug it in. If I plugged in 5, let's see, 5 minus 3 divided by 5 squared minus 5 times 5 plus 4, and I get a number, 0.5. I can plug in probably a negative number and I still get the same thing, which let's say, I'm going to have to insert things. -2. This is going to be, I'm just going to have to redo this, minus 5 times -2 plus 4. I didn't even put the squared there. I get a number. You guys can barely see that on the calculator. So what I'm trying to say is, okay, I plug in things, positives, negatives. What makes a fraction not work? And the answer to that is when the denominator is 0. 5 divided by 0 it's undefined. 7 divided by 0 is undefined. Whenever the denominator of a fraction is 0, it's undefined. So let's actually write down that note here. So all x values will work for this function except when the denominator equals 0. Okay, so what we need to do is we need to figure out what those values are that are going to make my denominator equal to 0. So what we're going to do is we're going to actually set the denominator equal to 0. So x squared minus 5x plus 4. We set it, and we kind of, so what I usually do is to remind me that it can't be equal to 0, but we're solving it by setting it equal to 0. And it's something that you guys have done in algebra. So this concept is what you guys would have done. And so to solve for x, the two x values that are going to make this denominator 0, we can do two methods. Now, we're not going to use the second method right now, but the two methods to solve for x when it's set equal to 0 is factoring and the quadratic formula. Now, with this one, and most of the ones when we're talking about domain for this unit, is going to be just factoring. So let's factor this. X squared minus 5x plus 4. I'm thinking what two numbers multiply together to get me 4 and add to get me -5. And if you're thinking x minus 4 and x minus 1, you would be correct. So now that I have it completely factored, remember, from Algebra 1, we can set each factor equal to 0. And then I solve for x. So I add 4, and I get x can't be equal to 4. I add 1, x can't be equal to 1. And those are my excluded values. Now, those are my excluded values because when I plug 4 back into the function, the denominator will become 0. So if we did that, let's say, okay, so 4 minus 3. Oh, let me find this. Oh, there we are. 4 minus 3 divided by 4 squared minus 5 times 4 plus 4. And notice how it says divide by 0 and it's an error. That's because when I plug that in, 4 squared minus 5 times 4 plus 4, I get 0. And any fraction divided by 0 is always going to be undefined. So let's write that down. These are my excluded values. And that's something you're going to hear me say a lot, excluded values. So when I plug 4 or 1 back into the function, the denominator will equal 0 and therefore be undefined. So we're essentially finding the output that doesn't work because every other input, or we're finding the inputs that don't work because every other input will work and give me a value. So how do we write this? Now you can write it like that. X can't be equal to 4, X can't be equal to 1. However, we're going to start getting into the habit of writing it in interval notation. Now, hopefully you've seen interval notation with in Algebra 1. Now, the way that I like to kind of remind you guys about interval notation is actually by showing this on a number line. So what this is saying is this function works for every single input except 4 and 1. So that means if I draw this on a number line, it means at 1, it can't be there, which is why we put that open circle. And then at 4, it doesn't work there, but it works for every single other value in between. Now this is going on and on and on to negative infinity. This is going on and on and on to positive infinity. So let's write this in interval notation. So interval notation is kind of how you would see it on a number line. So we'd write that, negative infinity to 1. Now it can't be equal to 1, so we put a parentheses. That means it can't be equal, which is why we put a parentheses for infinity also. You can't ever reach infinity, so that's why we put a parentheses. Union, that just means we're continuing on. 1, still parentheses, to 4, union, 4 to infinity. So I know this looks a lot easier to write than this, but this is something that we're going to be doing a lot in the coming future. So getting in the habit of writing it in interval notation is going to be important. So again, I like to use the number line. I think the number line helps me to get it into interval notation. If you don't need the number line, that's totally fine. You don't need to draw it, but there you have it. That would be your final answer to finding the domain of this function. Okay, we will do a review of this problem in class. I know that this one's going to be, our biggest question problem, but we will review it and go over any questions. So bring those questions. And that's it for me today. So have a great day, guys, and I will see you soon. Bye.